evening from Bangkok, everyone. Uh, thank you for joining us for Pre-RoboCup Humanoid League session. My name is Bantun Sesuwan. I am one of local organizing committee team, and today I am very glad to be here to serve as a host of this session. Today we have two speakers. The first speaker is Dr. Alessandra Rossi from the University of Hertfordshire from United Kingdom. Dr. Alessandra is a chair of organizing committee and she also is a technical committee. And one more speaker is uh, Jasper from University of Hamburg, Germany. Uh, Jasper is also a technical committee to in Humanoid League. Our speakers will talk about the introduction of the Humanoid League, rules and regulation, and some technical talk. Before we start, I just want to remind you that if you have any questions during the presentation, please type them into the question or chat box in your WebEx control panel. Our support team will bring them up during the presentation. And if the end of presentation, you can raise your hand by the reaction. So the host will be unmute your microphone so you can talk to you can ask with the presenter. Without further ado, we will turn the time over to Dr. Alessandra and Jasper. So please.
Thank you so much, Bantu. Hello, everyone. So welcome to the presentation of Humanoid League. So let's go. Bantu already kindly introduced me and Jasper. I'll just say a couple words more about myself. I'm also from the University of Naples, Federico II, and I'm a team leader of a humanoid kids sites team called Bold Arts, which is based at the University of Hertfordshire in UK. Jasper?
Yeah, hi, I'm Jasper. I'm from University of Hamburg, as Bantun kindly already mentioned. Thanks for the nice introduction. Yeah, I'm in the since 2016. I'm participating in RoboCup with the team Hamburg Bitbots from Hamburg, obviously. And yeah, I've been team leader for a while, and now I've moved over a bit and started working in the TC this year. And we have some exciting projects and changes we made since 2019. And yeah, we hope to show you some of the current state of our league in this presentation. Please go ahead, Alessandra.
Yeah, so I also have, as Bantun mentioned, I'm part of the C members and I'm also the chair. So I will talk a bit more with Bantun and the local organization with the DOC members. So moving on some more interesting part about the league. The league is composed by two sub-leagues, one kids sides and the other one is adult sides. As you can see by the picture, these are some of the robots of the teams competing during the years. The picture is from the 2019, and as the first things that you can notice, the difference between the two sub-leagues is first of all the dimension of the robots. So the smaller one from the kids sides and the adult side are the ones standing on the back. So the kids sides, as I said, are smaller robots. So their height is between 40 centimeter and 100 centimeters. This has been recently changed as limit because, of course, we want to at some point merge and having different challenges also for the kids size robots. All the robots need to have a human-like body. So teams can develop their own hardware, not only the software, but also the hardware. But they need to keep the proportion of a body, a human body. The teams in kids sides play 4 robots against 4 in 2 10-minute half times, and they played with the smallest version of the FIFA ball, which is the smallest one, a kid size one. And I'll show you a bit of the what is look like a competition between kid size robot. This is from 2019. The team Robo1 from France in pink, and Zua Dancer from China are the blue robots. As you can see, they move around the field. They need to be able to, of course, walking, localizing the ball, and when at the ball, take a decision, which most of the time is usually to kick it, and according also to their position to the robot. As you can see here, this is one of the really nice feature of also robot capability. So they don't need only to have the basic skills to play, but also to implement some more challenging human-like behavior, like, for example, taking the ball from the outside of the line and taking in. And as you can see, this is a bit of what is also like to be on the field next to it, looking at the games. And we, I think, wait, it went okay. So this year we received 16 submissions, so 16 teams applied to participate to the RoboCup 2022. It's a bit less number from the previous competition. The last one in presence was the submission for RoboCup 2020, when we had 20 teams. This, of course, is due to COVID condition, but we hope that with adjusting and improving the situation, we'll get back more per submission participant back again. Jasper?
Yeah, so I'm going to explain a bit about the adult size. So opposed to the kid size, the robots are much taller, adult-like robots between 1.30 meters and 2 meters. And because these robots are much more expensive, they are playing in 2 versus 2 games, so each team only has to provide 2 robots instead of 4 or even more. And the halftime is the same. And they play with a human-sized ball. This is the same ball that is used by adult soccer players. So this is the FIFA size 5 ball. But the same human-like body proportions apply to these robots. They also have to be human-like, and they can't just have extremely long arms, for example. Next slide, please. So we also have a short video to show you a bit how this looks. This is from the adult size final from 2019 between Nimbro and Sweaty. And you can see there's some people walking around on the grass as well. These are the robot handlers, because these robots are extremely expensive. We have to prevent them from falling over. You can imagine if you fall down as a human without having any kind of maneuvers to protect yourself, you will take quite some damage, and here we also see it. And then the robots are taken out by the humans, so we want to prevent this damage. In the future, of course, we want to remove as much of the robot handlers as possible. But for right now, it's unfortunately necessary. But they're not allowed to interfere with the game in any way. They are only allowed to pick up the robot if it falls down. But yeah, the field for this size is quite a bit bigger. So we have 2 sizes of fields as well, which need to be provided for this RoboCup. All right, so I think we can go to the next slide. For this competition, we have this year only 4 submissions because of COVID and difficult working conditions. Last time we had 7, so with the 4 teams, we will still be able to make a nice tournament happen. So next up, I'm going to talk a bit about the technical challenges we have next to the regular games. So we have a push recovery challenge, of which we'll see a video, which is basically robots having to endure several pushes of different strength. We have a corner kick where robots have to cooperate and they have to time it well, which we also see a video. A high kick where robots have to kick a ball over an obstacle. Currently in the games, most of the time the ball is only rolling on the ground, but as in real soccer, we would also have like to have kicks that are going into the air. Newly introduced for this RoboCup, we have the collaborative localization challenge, which I believe is inspired by the SPL, where one robot has to communicate to another robot who's blindfolded how to score a goal. So basically one robot doesn't know where it is, it has no vision, and the other robot has to tell it where to go. And then we also have a parkour challenge, which is also new for this year, where a robot has to step onto a platform and again from the platform down. The ground for the fields is usually flat, but here we want to have humanoid robots capable show their capability of being able to traverse other terrain other than flat ground. So yeah, now we're going to show you a small video of the push recovery. You can see here there's a weight from a pendulum which is being dropped onto a robot which has to be moving in that moment, and the robot can perform several actions to compensate for this push. So this strategy, which was done by our team, is basically just standing, and there's also other techniques which involve, for example, a capture step. So basically taking a step backwards to endure this perturbation better, to get back into balance. So the next video of the technical challenge we're going to see is the corner kick. So we have this robot on the left, which is positioning to kick from the corner, and the robot on the right, which is preparing to score a goal. So this is also a typical soccer situation where there's a corner kick, and the robot has to anticipate the ball coming to it or being passed to it, and has to perform well to score the goal then. Next up, we're going to show you a bit of what we're doing right now, and also what we kind of did during 2021. So we developed a Weebots-based simulation for the 2021 virtual competition, where robots play in simulation against each other, which is very similar in terms of rules to our normal competition. Some of the rules only have been slightly modified or slightly specified, such that they are able to be enforced by an automatic refereeing system, which was also developed for this competition. And because we already had the system and we wanted to continue to use it to let teams test their software against each other, we created the virtual season, which is a virtual bi-weekly competition where teams submit their software and the games are being run in simulation, and then we'll stream a video of these games, such that also with team commentary, so that we can further the interaction between the team members from different teams. And we also have a short video here how this kind of looks. And basically you can see it's let's skip the introduction. This is from the adult side, so they also play 2 versus 2. And here, this is in the beginning where they have to localize. You can see the field, which has relatively realistic lighting conditions, and which is in the same dimensions as in the real world. Here we have the kit size. We had to decide to only play with 3 robots because of computational constraints and time constraints. But this is basically also how it would look like in an ideal normal game. And yeah, this is the same system. The robots are fully autonomous as they are in the real world. They have their own software running. Each robot has a separate instance, and they can only communicate some small information between each other. and therefore they are fully autonomously playing against each other. So I think, I mean, we can watch this a bit further. I guess this is quite a long part where the robots are moving around the ball. So you can also see some capabilities which robots have to do. They have to be able to maneuver themselves in tight spots where they have to walk around the ball and avoid touching it, because otherwise they might kick it into the goal. And here we have a passing situation, which is coming up in a moment, where one robot realizes that there's an opponent in front of him. So it passes it to the next robot so they can out-dribble it. Some teams also had a lot of fun watching these games, and they were quite excited. So here on the right, you can see the team members which programmed the robots which have just scored the goal, and it was quite an exciting event, and it still kind of is for the virtual competition or for the virtual season we have right now. And we had a lot of games run, which is quite less effort than it is in the real world. So this also allows us to test our software much better than we could in the real world. At least, for example, the behavior parts. I mean, the motion parts, they would have to be tested on real hardware as well. So next up, Alessandro is going to talk a bit about the competition rules and what's kind of required there.
Yes, I will just give a brief overview. Jasper already mentioned a lot of them while describing the games. So the rules are based on or adapted from the FIFA rules, from the human competitions. And one of the most important part is that robots need to play autonomously, and they can use only the sensor. They are more human-like, so they don't have a depth sensor, they don't have a GPS or any compass, and they cannot use neither laser or infrared to build the map. So most of their input comes from vision, so through simple cameras and communication between themselves, which usually most of the time is done through, for example, technique like passing messages through Wi-Fi or other type of connection. Of course, there is a bit of human intervention in these cases, just to prevent that any type of damages to the robots or to the fields, and when some of them stop to work, so to avoid any further damage, because of course hardware is quite a bit of an issue, in particular to fix it during the competition. And something that actually we notice a lot also with the virtual season, with that teams are very more relaxed watching all the games. Instead, when they are in a physical competition, of course, they are always rushing to tidying up screws or making adjustments with the batteries and all the connection with the robots. All the robots, in particular in the kid sides, but also the other sides, need to be able, of course, to walk on the field. They need to be able to standing up from the front, on the back. In particular, the kid sides, they fell quite often trying to kicking the ball. So it's very important they can perform or human-like capabilities of a soccer human player. They also need to positioning themselves to the ball and kicking them according to the position towards the goal post. And most of the teams also have a more advanced technique, like for example planning or strategies between the teams and game strategies to play. And that is very similar, as Jasper already said, between the virtual and the real competition. Jasper?
Yeah, so next up, I'm going to talk a bit about the scientific challenges that teams are facing. As we are in RoboCup, we want to further science and not just play around, but also have some meaningful results. So in the beginning, there's of course the hardware design. Teams have to build a robot themselves. It's different to the standard platform league where they can just buy a robot. I mean, there's some robots available which can perform in our league, but it's often nice to modify these or to build upon another robot platform and have a better version of it, basically. And there's quite a few things that have been done in the past years in our league, which have furthered the development of humanoid robots. Then, of course, there's the motion task. The robots have to be able to walk into all directions. They have to perform other motions than just walking. They have to stand up if they fall down in kid size only. And they also have to kick a ball with a maximum force. So these are interesting control problems which are being solved in our league. And then they also have to do perception tasks. I mean, they have to know where's the ball, where are other robots, where's the goal, in order to be able to score a goal. And also in order to play as a team, they need to localize themselves. They need to know where they are on the field, so they know which robot, for example, has a better position to score a goal. And then merging this all together, there has to be a good planning framework. There has to be a good strategy, and this is a multi-agent problem, as it is in many RoboCup leagues. For example, the middle size is also a multi-agent problem, which is quite the standard platform. So this is often not the biggest focus for our league, but it's quite interesting to integrate approaches from other leagues, or also to develop new ones which are able to work on humanoid robots. So let's see some contributions which we have seen in the past. So here's one hardware contribution, which is the Nimbro OP2X, which is an open source robot platform. There are several open source robot platforms, which is really nice in our league, which are just shared freely and everybody can reproduce them. And what's also really nice is that it's 3D printed, which makes manufacturing it quite easy, actually, compared to having to have a big CNC machine and setting that all up. Its focus is on lightweight, being relatively lightweight. I mean, it's made out of plastic, which is often lighter than aluminum, even though you have to build different geometries with plastic than aluminum. And it's relatively low cost for its size. So if you look at other humanoid robots of the same size, they often go into the hundreds of thousands of dollars. And this one, I believe, is about 35 to 50,000. It's always quite difficult to say because there are so many parts that go into it. It's kind of hard to add that all up because, I mean, you don't count the working hours you spent assembling it. But yeah, this is one of the platforms. You also saw it in the video of the 2019 adult competition, and they won the RoboCup in adult size with this robot. So next up, we're gonna see a contribution relatively recent from 2021 in the field of perception. It's called YOYO. Basically, it's YOLO, but it also does segmentation. So often in perception, you want to segment an image. For example, for us, it's we want to know where's the field and where are the lines. Lines are very useful for localizing. And the field is also very good to know if something is on the field or if it's above the field. And basically the idea is to merge this into one big neural network, which does both and has two outputs. And this kind of reduces the processing requirements because you can share information. And it also generalizes better in the encoder stage of the neural network. because the features are required for both the segmentation and also for the object detection. Yeah, so now Alessandra is going to take over and give us one of the contributions from the planning domain.
Yes, of course, because you have the hardware and then you're getting the information from the vision. Now the robots should be able to do something about it, like humans. So they plan strategies and the ways to action to act according to the situational environment. So what's going on? And this is just to give a brief introduction from one of the publication of the RoboFay team, and that which combine both vision and planning together. Most of the strategy are connecting these two parts of the process. So they get first the information with the vision, and then they with this input, they will organizing the planning of all the tasks and the action of the robots. They instead tried to combine them together and creating the rules, in particularly for the goalkeeper, according to which the impulse goes directly on an action. So they combined both the efficiency of the decision tree technique with the deep neural network ability to process different data, and in particularly they use a framework, an architecture that takes the input from the vision from the goalkeeper, and the first deep neural network is trained to recognize what is the ball, and if there is a ball in the vision and where it is. If there is no ball, they'll pass to another neural network, which will decide whether is the action to do, either walk backward or do nothing. It cannot, of course, move around by FIFA rules, so you will need to stay either on the line or behind the goal line. So this is the wide two decision. Instead, if the first deep neural network recognize the presence of a ball, then it will pass the information. So the choice is to the third deep neural network, where it could decide the action to do according to the position of the ball. This is a particularly effective strategy because it does not need to know exactly where are the objects inside of the field of view, so detected. So it doesn't really need the full position of the ball, but just to in which area of the vision it is and how close is it towards the goalkeeper. And also this publication is the code and also the information, the data set are available on their GitHub, because they would like other to pick it up and try it with other robots, other systems, and to compare the resolution. For the testing, they used both a robot, real robot based on Darwin OP. As Jasper mentioned, most of the team started with some sort of already available platform, and then change it parts, replacing or improving the capability with the time. And that's something also this team did. And then they also tried on a simulation. So I would suggest who is interested to have a look at the contribution. We are, of course, it's just a bit of information where you could find. This is the website of our league, humanoid.robocup.org. You can find information not only about the rules and the regulation, but also all the teams participating during the years. And we openly, with all the league, discuss about the rules and if there are any questions on the forum. And of course, you can always email the TC and OC and follow us on Twitter. So actually, this is pretty nice. If you already don't follow us, please have a look. And thank you so much. Do you have any question?
Maybe I have one more thing to add.
Sure.
I mentioned the virtual season. It's currently being played, and if you want to know when exactly it's the next game is on next Sunday, so in 9 days, I believe. And you can find all the information about this on our website. I posted it into the public chat right now. You can see the schedule there and also where it's being streamed. So if you want to join in, feel free to do so. It's always quite nice to have, just watching the games, but also having the teams commentate on it and explain a bit more in detail what they do to achieve soccer playing behavior. But yeah, thank you everybody for your attention. I guess we're open for questions
now. Any audience have any questions? So you can raise your hand. So the host will be the host will let your microphone on.
So in the meantime, perhaps there's someone also have the courage to break the ice. Perhaps I think I would add also more to Jasper's comment that it's particularly important also the virtual season, because it is not just about a virtual game, but we are trying to have it more similar to real games in person possible. And we are also changing a bit of the challenges, for example, light conditions and the background condition, which of course go to affect the vision and it's anyway, it's a very good starting point for new teams who want to try to test their software without the constraints of the hardware.
Okay, I have a question. If I'm a new team, so what do you suggest that what should I do first from the standard one or build from my own one? So what you expect?
So we don't expect every team to build a new robot. That's not the requirement for participating in the Humanoid League. You can take the robot from another team if they have published it open source, and you can recreate it. You can also just buy robots. The Darwin, is it discontinued? I'm not quite sure.
It is.
I think the Humanoid, for example, is too small, but there are several robots out there which could be used. The Now, unfortunately, does not fit into the specifications because it has too large feet. So it has like gargantuan feet for this size of robot. But basically, you can pick whatever you would like to do, and also kind of it depends on your budget. If you want to build an adult-sized robot, that's kind of expensive because you have to expect at least $50,000 per robot, if not more. For a kid-sized robot, it's anywhere between 6 and 12 or 15,000. It also really depends on what you put in there. So it's kind of hard to say. They range in price quite a lot. But I would suggest looking at what other teams are using. So currently we only have the 2019 robot descriptions. But in a few weeks, when the submission is done, so I believe in 2 weeks or 3 weeks, you'll find on our website the qualification material that the teams have used or that the teams submitted to be qualified. And also there they have a detailed robot description of each of the robots that the teams are using, so you can look at what other teams are using. And also, as it's, I mean, we have a quite friendly atmosphere. If you find one of the robots from the teams very interesting and you say, I really like this robot, I can't find it anywhere, it's I don't know how to reproduce it, you can just contact them, and they usually reply.
Okay.
Yeah,
So
and also for the software, almost all the teams have open source software, and there are some they use custom based architecture, but there are also several that use ROS or ROS2 framework, so they can be applied to different robots and can be easily customized as well. So, and I second Jasper's comment that all the teams are very friendly, and we actually like to collaborate and share information and learning opportunity whenever it's possible.
okay, it's a good community for sharing. So I think there are no more questions. I have one more question for the
Sure.
simulation one. So very interesting. So what should I start if I want to participate in a simulation for the humanoid robot?
So I suggest looking at the current state basically of the simulation. We have some very detailed documents describing how this is done. And there's also some teams which basically just have all of their code open source. So for example, my team, not trying to promote too much, but we just publish it all, and you can look at what we do. So I believe that we are going to start this simulation league the next year. So basically between RoboCup 2022 and 2023 again. We'll send out a call for participation for that as well. I don't know when, maybe November or October, it depends on what we decide then. But if you want to start, I would suggest starting with these documents, and you can see how this whole infrastructure works on a technical level, and then looking at what other teams do and how they solve this problem, because it's like there's so many components to get a robot to play soccer, which all have to work, and if one breaks, everything breaks. So it's kind of nice to not reinvent the wheel. It was mentioned quite a lot also in the SPL. They are very good at sharing their software, and they have found a very nice way of sharing, but also having to contribute to that. And in our league, we are striving to get to this level. It's a lot harder because the robots are very different. But yeah, to participate in the simulation league, these documents and what other teams do is my biggest recommendation. And also just asking other teams. I mean, you can always ask me, I guess, if you have any question, if you want to participate. Or you can write the Humanoid League TC if you're interested in participation. We saw the mail address on the last slide, I believe. So it's rc-hl-tc@list.robocup.org. So yeah, we can then guide you a bit more on what you need to do, what you need to prepare.
Also, anyone can go through, or you have to participate in the RoboCup before, or general public?
To participate in the simulation, no, you don't. There's basically the requirements are there's unfortunately we have to make a fee, which needs to be paid because we have to pay the servers for running the competition. But if you provide the correct files and formats in the correct formats and so on, there's no barrier to entry for the simulation, and there's also no requirement for participating in the simulation to participate in the real competition. So these are basically the simulation is a tool for teams to during the year to progress and to evaluate their progress, and then transfer this back onto the real robot, or already develop it for both for the real and for the simulated robot. So these are not really independent because it's basically the same rules and the same environment, but or kind of the same environment, simulated real environment, but they are like in terms of participation, they are independent.
Look like we don't have any questions. So before we end today, so Dr. Alessandra and Jasper, do you have anything else you want to cover or before we end the session?
Not on my side.
I think we covered quite a lot, and of course we always are looking for new members, help organizing idea. The TC and OC are always open to contribution from everyone.
Okay, so great. So thank you again, Dr. Alessandra and Jasper, for sharing the information about the Humanoid League. And thank you, everyone. So we appreciate you being here. Thanks you again for joining us today. And we hope we will see you soon in Bangkok. So thank you.
Thank you so much. Bye.
Thank you so much.